Just like in R, we saw that R is the platform. R is basically the software on which the R Studio, which is the IDE, works, right? So just like that, you have Python, which is a programming language on which the Anaconda distribution of Python, which is one of the IDEs, works, right? So just like R and R Studio, you have the similar relations here with Python and Anaconda, right? Now, the slide that you are seeing on your screen is basically the Python shell, right? It is similar to your R. Here you can execute the codes line by line. Now, if you want to access your prompt, you can access it from here. You click on this and this will open. You just need to write Python over here, hit enter, and you are ready to use it. You can do any type of calculations. You can use it like a calculator. If you want to store a value, you can store a value like this: x is equal to 5. Now here x is an identifier, right? The way we call it in Python over here is x is an identifier. This identifier is related to a value which is 5. Here I have used equal to as an assignment operator, right? Now again, when I type x, hit enter, it will give me the value 5, right? Now this is your Python prompt, the shell that you have seen. So you have seen that we can do any kind of calculations, we can store values in it. Now this is your Anaconda Navigator homepage, right? You can access your Jupyter Notebook from here. You have Jupyter Lab, you have IPython Notebook or the Qt console. And this is another IDE which is called Spider. Now, if you look at Spider, Spider is very similar to your R Studio, right? And you can also install your R Studio over here. Now this is VS Code. VS Code is basically a text editor which you can use to write codes, and then you can import this file and execute it in one go. So this is your VS editor. And there are another versions like Bluebiz and Orange. These are different IDEs of Python. It's basically a text editor, streamlined code editor, right? Now you can have a look at the environment. When you click on the environment, it takes you to the page where you can see all the packages that are installed, right? So you will see all the packages that are there installed in it. If you want to find a particular package, whether it is installed or not, you can check for it. So Matplotlib is one of the packages which we use for data visualization. So we see that Matplotlib is already installed. Let us see if ggplot is there or not. No, ggplot is not there. So if we want, we can install those packages from here. Now from here, you can update the packages, right? Now a lot of content about the Python and the Anaconda distribution is given over here. And these are the most authentic sources about Python, the programming language. There are a lot of tutorials over here, and there are a lot of tutorials about the packages that we are going to use, right? So SciPy is there. SciPy is one of the packages which we will be using. Then you have the Matplotlib documentation. Now here you have the NumPy manual at my home page. I am going to new. From this new, from the drop down, I am selecting Python 3. Now when this page has opened, I click on this untitled 6 and I name it DSP26. Now it has been renamed. You go to the home page. From the new, click on this new. From the drop down, you select Python 3. Having done this, a new notebook will open. You click on this untitled 6 and give a name, whatever name you feel like. So now you know how to name the page, right? So you have learned how to name the page. Now you can use these blocks, right? These are code blocks, right? You can use these code blocks as a markdown cell or as a heading or as a pure code block, right? So if you want to use, let's say I want to give a heading over here, right? Heading is uh, how to name the notebook, right? Having written this, how to name the Jupyter Notebook, I go to this particular tab. From the drop down, I select heading. Clear? I click OK. Now, to get to the next code block and execute the current one, you just need to hit Shift Enter. Clear? Now this is a heading and this is your code block. Now, if you want, you can use these code blocks for heading also, for comments also. Now for comments, again, we will use the hash sign, right? Now this is treated as a comment. Now there are multiple ways in which you can run your code blocks. You can run it using this run, or you can run it using Shift Enter button from your keyboard, right? Suppose you write 2 plus 5, you click on run and you have the output. Now there would be situations where your notebook would become unresponsive, right? Which means if you have written something over here and you are trying to execute the code, it will not give you any output, right? And you will see a star sign over here. Now that should give you an indication that your notebook has become unresponsive, right? So in that case, what you need to do is you need to go to this kernel tab, click on the kernel tab and click on this reconnect. Now, in order to set the working directory, we need to import some of the features of the operating system. So everybody please write import OS as OS. First, give a heading, setting the working directory. This is a markdown, which is again, another thing is the markdown. You can use this at a markdown. Markdown simply means that this is not a code, and this is a, some kind of a heading, right? So import OS as OS, and when you write os.get cwd, this is going to give you the current working directory. Now, if you want to change the working directory, this is how you do. There you were doing what? Set wd. Here it is os.chdr, change dir. And again, put the name of the path. Put the path, right? Now, import is just same as loading, right? Here I am loading the features of the operating system. Yes. No, Archana, whenever, in Python, sorry, in R Studio, whenever we wanted to load a particular package, we used to run the library command, right? Now this import is equivalent to library here. Import is equal to library. There are a lot of packages which we will have to install, right? So I was talking about the package Pandas. Now this is how you install a package in your Python, right? This exclamation sign, pip, install Pandas. This Pandas can take any name here. If you want to install scikit-learn, it will be sklearn. If you want to install NumPy, it will be NumPy, right? So please install Pandas. Once you are done with the installation, as I told you that you need to load the package, right? And whenever you have to load the package, you use the import function, right? There in R Studio, you were using library. Here it is import. And another very important difference in Python is that whenever you want to use a particular package, you have to use the name of that particular package, right? So suppose I want to use the package Pandas. So every time I will have to write Pandas followed by the function of Pandas which I am going to use. So to prevent us from writing the complete name of Pandas or the package, Python gives you the option of creating an alias. So you can create an alias, right? Like if I have to call you, right? Arpan Sharma or Sai Shrikant Neela. So I can simply call Sai, right? So similarly, when you are using Pandas, you just need to write the PD. This is the nickname. We are importing Pandas and we are giving a nickname to Pandas, which is PD. You can give any name, but by convention, people have been using Pandas as PD, right? You have to import once, right? In every session. and you have to install a package once in lifetime. But you have to make use of the name of package whenever you want to use any function of that package. That is why we give the name as PD, a short name. Yeah, if you don't give a name PD, if you don't give a name PD, you can straight away use pandas, right? That is not a problem. But this basically saves you time. Now, this is the other package which we will be using extensively, which is the NumPy package to handle the arrays, vectors, etc. And again, this is how we install it. This exclamation sign pip install NumPy. So this is the areas that I have given to NumPy. Now this is the package which we are going to use extensively for the plotting of histograms, box plots, etc., which is Matplotlib. Now in Matplotlib there is a function pyplot, right? Now I am importing the pyplot from the Matplotlib as PLT. Now scikit-learn is the package which we are going to use in each and every session, because this has all the functionalities which you will require to carry out machine learning tasks, right? So the name here is sklearn, which stands for scikit-learn. Pip install sklearn, and in RStudio we were using different packages like CA tools or the sample function to split the data, but sklearn here gives you a function which is train test split. So we will use this function of train test split, and then for importing different machine learning algorithms like k-nearest neighbor, we will write from sklearn.neighbors import k-neighbors classifier. For logistic regression, from sklearn.linear model import logistic regression. Similarly, we will be importing other packages like decision tree, SVM, linear regression, etc. Can you see this star? Now, this means that my notebook has become unresponsive. Now, what I will do is I will go to kernel, either reconnect or restart. See, oh, actually it was not unresponsive. It was just in the process of doing the installation. That's why it took so much time, right? But the only technique to get rid of such problem is to reconnect. Now, Seed1 is another fantastic data visualization package. You will get it here itself. When you write a code block, right, for data visualization, suppose you write the histogram code for here, then the histogram will come next to this code block. Now, this is there are some functionalities which are common between your Matplotlib and Seaborn, but Seaborn I think has some better functionalities as far as your heat maps are concerned. You can create excellent heat maps using the Seaborn package, and this is how you import install cborn, pip install cborn, and you give the name alias SNS. Cborn is again for data visualization, right? We can create heat maps with the help of cborn. A lot of plots can be made with the help of cborn. You can create a density plot. A lot of things can be done with the help of cborn. You have to ensure that you use capital wherever I have used cap locks. So K, N, and C are in capital. Now there are some pre-installed packages like date time. So you can calculate. These are some of the fun things. Like if you want to calculate the exact number of days between two given dates. So here is date 1. So 23/11/2013. Here is date 2, 6/4/2019, using the date time dot date. See, here if you look at uh, what is the observation? What is your observation? Can somebody tell me? There is something important which I just told you a short while ago. We are using the date time package over here, and in order to make use of the date time package, I have to write the date time over here. Now, if I had imported this import date time as DT, right, then I would have saved the time worth 5-6 keystrokes, right? So here I have to write the complete date time dot date. Then I am giving the first date minus date time again to make use of the date time function. Date again with this value. You have to make use of the date time function every time. If you have not given any alias, you have to write it completely. So these are the small differences from your R. So you have seen the shell, you have seen Spider IDE, you have seen IPython notebook, right? So we have become familiar with the Anaconda Navigator. So we have already seen all these things. If you want, you can also install your RStudio. See here, look at my output. You should get an output like this. It will calculate your total number of days between these two dates. If you want to calculate what is the total number of days between today and the previous day, the total number of days is 2171. Okay, so this is how your code block looks like. We have seen Spider. So we know how we can assign values. Okay, data structures, right? Now, there are some data structures which come under the primitive group, and they are your integers, floats, strings, and booleans. So they are very much similar to what we have seen in your RStudio. Your integer would be basically a whole number like 10, and a floating point number would be something like 10.25, right? And a string would essentially be a character variable, right? If I write the name Akshay, and if I give an identifier a name to it, then if I check what is the type of name, I will get str. And these Boolean values are your trues and false. Then your non-primitive data structures are arrays, Arrays are like your, they can be n-dimensional arrays, or they can be vectors, anything. And then there are lists. Lists are a type of object, a data structure, which has the beauty that it can have elements of different data types, right? So we will look into each of these in details. Then we have tuples, dictionaries, sets, and files. So we'll look into each of these in detail. There is nothing much to understand. Float is something like this, 3.7. Okay, another important point is that if you do a division, suppose you are dividing 4 by 2 in Python, then you are always going to get a floating point number, which means you will always get a 2.0, right? Now, this was not there in Python 2.7. In Python 2.7, you would have got simply 2, but in Python 3.5 onwards, I think we get 2.0. So a division always produces a float. This is something which you need to keep in mind. And if you have a floating point number, and if you are doing a multiplication, then always the result is going to be a float, right? Had it been even 4.0, even in that case, this would have been 8.0, right? So in case of multiplication, if one of the elements is a floating point number, the result is always going to be a floating point number. But in case of division, whether your, and same will be the case with addition, if you try to add two floats, the result will be a floating point number. Similarly, in subtraction, multiplication, now this is a quotient division, right? And this is a remainder division. So suppose you are trying to divide 5 by 2, right? So you write 2 over 2, you get 1. So this x percentage y sign is going to produce 1, right? And this is going to produce this 2. So these are two types of divisions. One is the quotient division and the other one is the remainder division. And this is the absolute function. So whatever value you give over here as an argument, it is going to give you the absolute value of that element, right? Absolute value simply means if you write ABS minus 11, you will get 11. Now this is the exponentiation, right? This is very similar to what we were doing in our studio. This is exponentiation. Yeah, there is no difference in the output. But here, when I saved it in Z, and here if I wanted to get the output, then I will have to use print Z, right? If you are doing a direct multiplication and executing that code, then you will get the answer. But if you are assigning an identifier to this calculation, there you will have to use the print function. Otherwise, it is not going to give you the value of Z. You will just see it is not giving you any value, right? Because the value is just getting stored. So here you have to write print Z. Okay, then we have the string. Now there is something very important about strings is that these strings are not collection of alphabets. I will not agree with this. They are collection, but then they have got a sequence, right? The sequence is important in case of strings because a sequence has a meaning over here. If and why I am saying this is if I am assigning this cake an identifier X, and if I want to take out the second element, right, I can do that. That's why I'm saying strings are collections of alphabets, but with sequence having its importance. And another important thing about strings are that they are immutable, which means you cannot change the value of a string in place. In a string, see, a collection of alphabets simply means that you have put all the values in a bag, right? But what I'm saying is strings are not collections, they are sequence of alpha of elements, right? And why I am saying saying this is if I have to pick this element, I can use the index number. If I have to pick this second element, I can use the index number of this element and so on, right? That's why it's a sequence of elements, be it alphabets, be it word or any other character. Now the flexibility here is that you can have anything in that within the double quotes, right? But then you cannot change the values of the elements in place in case of a string. I'm creating a variable, an identifier, mystr, right? We are learning Python today, right? Now, if you want to replace this V, right? You cannot do that. I will just show you why. See, if I want to pull out these two values, I will write 0 to 2. We have got V over here. Okay. Now, if I want that this V should be replaced with some other value, it will give me an error. If I write it like this, see, it says str object does not support item assignment. You cannot change the values of an str, and that's why the presentation says that strings are immutable sequence of characters. This is the best definition of a string. Strings are immutable sequence of characters. Now, another important thing which I don't know if you noticed or not, that Python, the indexing is zero based. Now, what do I mean by that? This element has got an index 0. This element has got index 1. This space is 2. This A is 3, this R is 4, this E is 5, this space is again 6, this is 7. This is zero based indexing. What we were doing in R, if I had to pull out these two characters, what we would put in the square bracket? 1 and 2, right? But here we are writing 0 to 2. And you cannot change the items in place. That is why your slide says that strings are immutable sequence of characters. If you want to print characters from the end, right? Now, another important thing is that now there are two ways in which you can index. One is forward indexing and second is backward indexing. Backward, right? Now, in case of forward indexing, I told you this is going to be 0, this is going to be 1, this is going to be 2, and so on. In case of negative indexing or backward indexing, this is going to be -1, this is going to be -2, this is going to be -3, and so on. So you can use either forward indexing, or if you are interested, you can use backward indexing. Now, just like we had length in case of RStudio, here we have LE and len, right? Now, my string dot upper is basically, this is a method, right? This is called a method. This method is changing the case from lower to upper. Now in RStudio you have to lower to upper. Here you have my string dot upper. Now this is a method. Length gives you the length. Type gives you the class. Here it says it is str. And when you are trying to subset my string 0 to 5, it will take the elements which will be 1 minus the last one. It will go up to the index 5 minus 1, which will be 4. So my string 0 to 5 will start from 0, take the second one, go to the third one, second one, third one, and fourth one is the gap. That's why you see here it includes IM and gap. This is how you create, right? This is how you create. If I am putting anything between double quotes, I'm simply creating a string. That's it. If I put a numeric value, let's say 1000 within double quotes, then it will not remain an integer, it will become a string. You have the option of selecting the alternate elements, right? Here I have written my string. Before semicolon, I have not given any value, so it is starting from the beginning. After semicolon, again I have not given any value, it is going to the end, and I have given 1 as the incrementing value, which means it will go to each and every value. If I replace this 1 with 2, you will see that the alternate elements are picked. If you replace this 2 with 3, again 2 elements are 2 elements are being dropped in between. Here A and this gap has been dropped. From I, it goes to the third element. If you write 2, it will drop the every second element. Now my string -1, this is the example of negative indexing. It is going to take the last value, which is y. And here we are reading from the beginning to the end, but we have used the negative indexing over here. So it is reading from the last, right? Similarly, you can start from -4 and you can go to -1, right? These are again some examples. Now, in case of the strings, if you write the multiplication sign, it basically acts as a concatenation, right? It joins the string twice. Similarly, your plus sign also works as concatenation and it adds the two strings. It will basically give you the index. X is greater than y and x is divisible by 5, right? Just look at this value, right? What is this? Let me copy this. Now I am going to the place here. I am saving that value. I am giving it x equal to this. Print x. Print id x. Can you see these two values are different? They are referring to different memory locations. See, we were talking about the truth table. Now, if A is true and B is true, and then if we are using the OR operator, then it can be true, right? And it will also be true if one of the A or B is true, right? So that's the case here also. One is true, that's why it is true. And if both are false, then it will be false. So for true to occur with OR operator, even if one of the values is true, you will get a true. And if and only if both the values are false, you will get a false. Now, lists are mutable, right? Unlike strings, your lists are mutable, and another feature which differentiates the list with a string is that a list can be changed in place, right? A list can be changed in place. Item assignment is possible, which means in simple terms, if you want to change a particular element in a list, you can do that. And a list has the flexibility of having different types of elements. In fact, a list can have a list in itself, and a list can have an integer, a float, a string, a list, a bool, everything in itself. A list is again, a sort of a sequence, right? And just like we use the indexes to subset the items or the elements of a string, we can simply use the indexes to subset the list items. Let us see an example. So here we are creating a list which is X, and X has these many elements. Now, if I want to change the item 0, which is this 1 over here, I can do that, which was not possible in case of your string. Now here, if I am changing the first element from 1 to 999, it got changed. And your negative indexing also works over here. Here, if I am doing -1, it will pull out this last value. Again, the indexing starts from 0. This 999 corresponds to the index number 0. And this is the concept of a full slice. Here I have left the first and the last element blank. You are saying you want to create 1 to 10, right? Give it a value y, and then check what is the type of y. Negative indexing also works fantastically over here. This is the last element, which is having backward index -1, negative index -1, and this is the first index, forward indexing, it will be 0. Now you have a method which is called append, right? Now if you want to add some element in this list, right? If you want to add some element in this list, you can use the append method, right? This will append this value in the end of the list. See, here this value is getting appended. Now again, this is similar to what we did in case of a string. Now this is called a full slice, which I was talking about. Now full slice, this concept is very important because here you are creating a copy, right? Here you are creating a copy of X, and if you check the location of X and X full slice, it will be different, right? And what does it mean? It simply means that whatever change I do on X will not have any impact on the full slice. Here you have an element X. There is that element X, right? We have created X over here. So X is that. Now let us see what X is. I am just adding one code block over here. X is this. Now I am creating a full slice of this list, right? This is how you create a full slice, right? Now, okay, first of all, you understand what slice is. See, if I take elements starting from 0 to 5, this is a partial slice, right? Which means I am taking all the elements from 0, 1, 2, 3, and 4, right? It will take these 5 elements, right? Now, if I remove this 5 from here, and if I remove this 0 from here, which means I have left the first and the last index blank, then it is going to copy from the beginning till the end. Is it clear? And that is the concept. Yes, it is like creating a replica, right? It's like cloning, right? We have created another X, which is a clone of this X, and we have given it a name X full slice. Now, if you check what is the ID of this X and what is the ID of this X, it will be different, right? Now, if I suppose in this X, I append this element 789, right? So now if I print X, 789 has been added over here. And now if I print X full slice, I hope this is the name. Yeah. Now if I am printing X full slice, see, X full slice remained unchanged. Clear? X full slice remained unchanged. That is the whole concept. Now you can also concatenate a list to an existing list, but to concatenate a list, you must have a list. You cannot concatenate a simple 99 to a list. See, it will give you an error if I remove this from here. It says it can only concatenate list, not integer to a list. Right? But if I put this, it will be able to concatenate. Whenever you are leaving the first and the last index clear, right? You are not writing anything about the semicolon, and after the semicolon, then it is a full slice. It is making a copy, a fresh copy of the X. Now you can also use the function sort, which is similar. Now there are things like if you want to insert some value, you can do that. Here I am inserting Z at position 5, right? That is what I am doing over here. We can use it to clone data set so that we can, so that you don't affect the original data set. That is the whole concept. The next data structure is array. Arrays are a type of list. The difference here in case of arrays is that it has all the elements of same type, right? Now in list, what we saw that the elements can be of different type. It could be int, float, str, or even a list or a bool. All of the things can be included in a list. But in case of arrays, all the elements of an array are going to be of same type, and indexing, just like it works in your string or in case of your list, similarly your indexing also works over here. Now, the tuples and lists are again similar in the sense that the tuples can have elements of different types, but the edge which tuple has over a list, or the restriction that it has over a list, is that the tuples are immutable. Just like your strings, a tuple is immutable, which means you cannot change the value in place of a tuple. So that is the basic difference between a tuple, and the similarity between a tuple and a list is that it can have elements of different types, as we are seeing over here. It can have int, float, str, and boolean. We cannot change the value in place. You can add a value to that tuple. So this 100 gets added over here. My tuple plus means whatever is there in my tuple, you include that and add 100 to it. And you can see that I am adding a tuple, right? This is a tuple. This 100 that you see over here in line 69 is basically a tuple. Now sorting will work in tuple as long as it has the elements of type numeric. So you can make use of the function sorted, and it will give you the sorted values. I will see how we can I'm just forgetting this, how this works. Then you have another data type which is called dictionaries. And a dictionaries is characterized by a key and a value pair, which simply means that this is the key and this is the value, right? So it has got a key value pair. We see there are 1, 2, 3 key value pairs, 4 key value pairs, and you can index the value using the keys. So these are the marks of Sarah, Sachin, Neena, and Sheena. Now, if you want to pull out the marks of Sarah, you can just put the key of first element, which is Sarah, and you will get the marks that is corresponding to this key Sarah. Similarly, if you want to use the get function, you can use the get function to get the value corresponding to the key Sachin. Len also works perfectly. If you want to add a new element, this is how you add a new element. You just put the key name over here in the square bracket, and you assign the value. So basically what you are doing is you are creating a key value pair, and now when you again call this marks, you see that this last element Ravi is added over here. Now this is again the use of sorted. Now here we are sorting all the values, and we are putting the keys in the sorted values, sorted order. Now this is a pop item. Pop item arbitrarily, removes one item from the dictionary. Now, if you want, you can put the name of the person whose name you want to pop out, and it will pop out or it will delete the name of that person from the list or the tuple, right, or the dictionary. You can do this with the help of marks.del item also, but difference between del item and pop item is that del item will simply delete the value and does not give you any output. But if you are using pop item, it will delete that particular key value pair and also return the key value pair which is being removed from the dictionary. I hope you understood what is the difference. See here, if you delete the marks of this key, which is Sarah, it is going to delete this value, but it is not going to give you any output. Just a minute. I'm saying pop item will arbitrarily remove one item at a time. If you run this pop item second time, it will remove another item. So let us see what happens. As of now, there are 1, 2, 3, 4, 5 people in this dictionary. Now, when I am doing the pop item, let's see which item it removes. It removes the last item. And now when I print what are the keys that are left in the marks, it shows all the keys without this key which was popped out, right? Now, if I want to delete a particular key from the dictionary, then I am putting this name of that key, but here there will be no output. It will simply delete this value from this marks. If you again print marks over here, Sarah is removed, but this del did not produce any output. But pop was able to produce an output, and it gave you the output of the key value pair which was removed. That is the difference. Just remember, pop will give you an output, delete will not give you an output. Delete will simply delete the value. List always has list. We create a list with this square bracket. In tuple, we are using this bracket. In dictionary, we are using this bracket. Okay, let us come to the control structures now. Now, the best part about the Jupyter Notebook is that it automatically takes care of the indentation, right? Indentation, I mean this space, right? Now, your Jupyter Notebook automatically takes care of this. And the basic concept for the for loop remains same. You use the for loop when you know how many times you have to perform a particular operation, right? So here we know that there are these number is given to us, it is 10, and for I in range 10 we are printing the I plus 1, and then we are printing this value I plus 10. So this is iteration number 1 and the value is 10. The iteration number 2 value is 11. Iteration number 3 the value is 12. Similarly here I want to print all these values after multiplying it with 9. So I have written for I is the intermediate variable which takes the value 10 in the first round, to 20 in the second round, 30 in the third round, and every time it multiplies it with 9. And this is how the output is generated. It works similarly in case of your string. For I in this string, print I, this I will iterate over all the values starting from 0 till this n, and it will print all the values including the space. Then you have the if else construct. Here I have written x is equal to 14, which means I am assigning the value 14 to this identifier x, and then I am checking the condition, and the condition is that if x is divisible by 2 and it leaves a remainder 0, then print x is divisible by 2, else print x is not divisible by 2. Now see what happens when I make this 11. It will print a value, it will print x is not divisible by 2, right? If I make it 110, it will print x is divisible by 2. Summing up all the even numbers, right, from 1 to 110. So I'm creating one container for holding the sum of even numbers. I am assigning it a value 0, and then I am saying for I in range 1 to 102, if I is divisible by 2 and it leaves a remainder 0, then sum EV is equal to sum EV plus I. Print I and sum EV. Now I am using the for loop and the if loop to calculate the sum of all the even numbers starting from 1 to 102. Just look at what happens when I move this print to here. It is printing every loop, every iteration it is printing, right? So what simply means is this print is getting executed in each and every iteration, right? Sum EV is equal to 0 for I in range 1 to 102. If I remainder division by 2 is equal to 0, sum EV is equal to sum EV plus I. Print I, which means the iteration, first iteration, the sum of value is 0, the sum of even numbers. Then in the second iteration, I takes a value 2 and the sum of EV is equal to 0 plus 2. That is how we get 2 over here. In third iteration, the value of I becomes 3 and the control directly come if I divisible by 2 is equal to 0, which is it is not, then it simply comes to here, right? Here it becomes false when I is equal to 3. Then the control simply comes over here and it prints when the iteration is third, the sum is equal to 2. In fourth iteration, again, it takes a value of 4 and 4 is divisible by 2. So it takes 2 plus 4. In first iteration, it checks is 1 divisible by 2, which it is not, right? So it prints this value, sum v is equal to 0. It does not go to this place. It straight away comes to this place. The control comes over here. Now, again, the control comes back here. It checks is 2 divisible by 2, which it is. So, sum EV is equal to 0 plus 2. That is how this whole output has been generated. But if you move this back, this loop will keep on moving within these 3 lines. And only when the loop gets terminated, the control will come over here. And in that scenario, only this last line is going to get printed. See what happens. Here, the impact is that when I move this print back, this print will come, this print will work only when this loop terminates. And this loop terminates when I takes a value 101. And then the loop terminates and it prints 2550. Now this is the usage of the in operator. If you want to find whether a particular string is there in the string or not, you can use the in operator. Now you have the if-elif statement. Now user input, this is how you can seek an input from the user, right? User input is equal to input, and then there is a prompt, enter your age in numeric, right? Now once the user enters the name in numeric, then that is basically stored as a character. So you have to take that character and convert it into integer, and then the if and elif else loop follows. See how it works. Now it is asking me to put my age, right? User input is equal to input. Enter your age in numeric, right? Suppose I put 40, right? Now, if I hit enter, it will say full ticket required. Suppose I put 3 over here. It says no train ticket required. If I put 10 over here, it will say half ticket required. Is it clear? Now you have the while loop. Now it's very similar. Now you use the while loop when you don't know as to how many times a particular operation has to be performed, right? Now in case of while loop, you want to perform an operation till the time a certain condition remains true. The moment the condition becomes false, you break the loop and you print the output. That is what is happening over here. X is equal to 0. Then I am saying y x is less than 10. Take x, add 1 to it, and I am creating another identifier. I am saying multiply x with 15 and give it a name y. Print iteration number x and value of y is y. Print the value of x is x. See what is happening. Iteration number 1, value of y is 15, value of x is 1. If you want, you can move it back and it will again get affected only when the value of x becomes equal to 10, and when the value of x becomes equal to 10, this while loop breaks because this condition becomes false. And then whichever part is indented, it simply means that it is covered with this, it is indented to this while loop. And this is not under this while loop, which simply means this will come into action only when this while loop terminates. Now this is the usage of continue. Continue, if you see this loop for I in computer, if I is equal to t, continue, print I, which simply means that the moment the I takes the value of t, this loop, this statement is not executed. It is basically skipping the value. This is your continue structure. Then we have the break. For I in computer, if I takes the value p, break and print I. So the moment I becomes p, rest of the loop is not executed. Understand the set operations using the NumPy package. Please import NumPy as np, and we are also going to learn the array. Now we can create array using the NumPy package. So we are creating set1, and set1 is an array of 3 objects, which is desk, chair and bulb. And set2 is an array with 3 objects, lamp, bulb and chair. Here I have printed S1 and S2, and now I am printing the intersection of the set1 and set2, right? Or basically the array S1 and S2. So intersection simply means it will print all the elements that are common in both the elements, both the S1 and S2 arrays, right? So this prints bulb and chair because bulb is here, chair is here and chair is here. So it prints bulb and chair. And then you have the union. So union simply prints the complete set, and it takes one element and it takes the element of both the arrays, set S1 and S2. Creates a subset of the common element in both the arrays. Union, it creates a complete set. Set difference, it pulls out the element which is not there in the second array. So desk was there in the first S1, but it is not there in the S2. That is what set difference does. Now you can also print in 1D. This is again the in operator. It is simply checking which all elements of S1 are in S2. So S1 elements which are in S2 false true, true. Intersect is basically giving you the output as the common elements, right? Intersection is giving you the common elements, right? Here it is giving you Boolean values, true, false. And this is saying that the elements of S1 which are in S2, yes, in whenever you are using in 1D, it is going to give you true, false. Every time we are using the NumPy package, we are using the alias. Every time, right? Every time, which was not the case in R. See, now you can select. These are all the functions that are available in NumPy.